Let's set a few things straight. The Earth rotates once every 24 hours. The Moon rotates around the Earth once every 27.3 days, if you want to be exact. Let's call it 28 days. It matters not where the sun is, because it's just here, but you could put it as far away as you like and just have to have a stronger light to represent the sun. So it makes no difference if the sun's 93 million miles away or 250 trillion miles away or 1 mile away. It just depends on if you can get the light to shine to the Earth. It makes no difference where the Moon is in relation to the Earth, whether it's this close or whether it's a lot further away. The distance away makes no difference. What does make the difference is how long is a month. And a month is determined by how long it takes for the Moon to go from this position around and back to this position. That's a month. This model here is wrong at the moment, obviously, because the Moon is attached to the Earth and it's spinning at the same rotation. But as you can see, you watch America here, where'd the shadow go? The shadow went west to east. Now that's what they showed us during the eclipse.
Is that 2 minutes when or 2.5 minutes when the Moon completely covers the sun. The sudden darkness of totality is just something that a lot of people can't compare to anything else. I love the idea that I'm giving this kind of map to other people, and
eclipse.
Especially that it's...
But I know that you people watching are saying the Moon does not follow the Earth like that, because if it did, Australia here would never have a moon. It would always be stuck on America, correct? So the Moon travels slower than what the Earth travels. The Earth's doing a 360-degree rotation in 24 hours. This clock it doesn't determine, but we've made up the clock to go 24 hours from here when it turns around and comes back to here. That's the Earth's rotation. Now, the Moon's rotation from here around to here, back again, is 27.3 days. So the Moon moves slower around the Earth than what the Earth is moving. Fair? Because that's what all the textbooks say. For the Moon to travel from here to here, a quarter, is about 6 revolutions of the Earth. So the Earth has to rotate 6 times for a quarter of the Moon's distance from here to here. So it's got to rotate at least 6. It's probably 7 or 8, but let's say 6. So the Moon's going to go from here to here. That would represent 6 turns of the Earth. So let's speed the Earth up a bit. Let's count the rotations. There's America 1. It's going to be slow, but let's just wait. Oh, that was 2. Sorry, I missed it. 2. Remember, 6 rotations are going to take the Moon from here to here. Okay, let's do it again. There's 1. Now the Moon's slowly moving. 2. Now that you're going to lose the shadow. But do you understand that the Moon is moving fast, but it's in relation with that, it's moving slow, because the shadow travels across here about 1,000 miles an hour. That's not disputable. The dispute is that the Moon is moving around the Earth slower than what the Earth is rotating, which means you now have an east to west rotation of the shadow. Watch again. There's America. And see how I'm moving, but I'm not moving as fast as the Earth. Watch again. Comes up in the east and sets in the west. So I'm actually moving the Moon too fast because it's 6 rotations between here and here. 7 or 8. But let's not be pedantic. It doesn't make any difference. All I'm trying to show you is that this is going to rotate always faster than this. So as long as this is rotating faster than what this is rotating, you've always got a shadow going from east to west. Get it? The only way you can have it any other way is to make it work. Comes America, and there goes the shadow. It went from west to east. That is wrong. The Moon does not go the same speed as the Earth in its rotation. So the conclusion is, you give me a conclusion. Our heliocentric model doesn't work. Thanks for watching. I would ask someone to do the experiment as well. I don't want written words. I don't want theories on a piece of paper about speeds and distances and directions, because they are all basically irrelevant. 360 degrees rotations is relevant. Distance from the light from the sun to the earth is irrelevant. Okay, we're only talking about a shadow going west to east or east to west. How can you make it go west to east by having the earth still doing a 24-hour rotation, doing 360 degrees in 24 hours, and the moon doing a 27.3-day rotation in 1 month, which is about 27 revolutions of the earth? I'll leave that with you. I hope someone can give me an answer, because so far NASA can't. Lots of smart people can't. Lots of people are giving me theories on pieces of paper. That's nice, but show me a model. It's pretty easy. It's a torch, a globe, a drill, and I've got a bolt there representing the moon.
The moon circles the Earth every month as it cycles through its phases, lining up at both full moon and new moon.